Hi, thank you for getting to this channel. Thank you. This channel is made for civil engineering, student building, and of course water engineering. So I have a question on simple curves. A question on simple curves. Simple curves. So this is application question that goes when you want to set a curve and then we get to obstacle. Yes, get to an obstacle. So for example, let me just demonstrate. You have a curve. This is a curve. This is a simple curve there. Just don't mind my drawing, it's just a demonstration. So you have to, this is a simple curves. It's just application from roads. For example, you have been told the road was designed to come this way. Then it means if let's say a mountain was here, or a river. So now the road needs to make a turn. A turn leads this way. So for this road to make a turn, we need a smooth curve, a smooth curve that comes this way. For a curve to be smooth, that's why we have so many formulas of setting as a curve. So for a curve to be smooth, we have to get this distance, which is a curve length. We have to get the chord. So now let's say. So the question our question now, tell us that this question is application when an obstacle is here. Now let's say for those common questions, we normally have the deflection angle. We can access the deflection angle. We can get the angle of intersection, which is here. The deflection angle is here. We can determine the chainage at point of intersection, which is here. But now you have told that the river passes here. The river now is here. The river, which is an obstacle. The river passes here, so we cannot determine the deflection angle and angle of intersection, change of point of intersection. So now here we use what we have from here to get the unknown. So I'm going to do this one. It's normally brought in exams. For example, 2021, I think between 2021 2022, those papers is normally set. So the question is here. So the question goes this way: two straights Pi and Qi meet at inaccessible point I. Point E and F, I've repeated here, and F and were established on a straight Pi and Qi respectively, such that the distance EF is r meter. Full stop. The angle PEF was measured as this one, and angle QFE was measured as this one. Full stop. If the radius of the circular curve joining the straight is 600 meters, calculate the distance I from E and F to the respective tangent point. Then, if the wrap this one is not important. So draw the chainage of the point of intersection is. So the point of intersection is here. We have been given the point of intersection. Tabulate the deflection angles required to set out the curve, assuming that point R required at every 20 meters of the chainage. So the first thing you have to do is sketch using the information given here. Sketch a curve. You can't just go through without a sketch. First, sketch a curve using this information that we're given. So for my case, I did it, and it is here. So I don't want to waste so much time. So I did it here. I sketch. This is my sketch now. Let's see if I sketch it correctly. So I've been told two straight. So two straight at this line, and this one. So straight is pi and qi. Yes, meet at inaccessible point I. It means here point E and F were established on the straight. So E and F were established on both straights. Then such that EF is 100 meter. So this here is 100 meter. And then the angle of PEF was measured as angle PEF. So this angle now is this one, and this one is, yes, if the radius of the circular cap, I've been given the radius is to be 600 meter. I've already put it here. Then now we can get this one. Calculate the distance I from E and F. So this distance and this distance to the respective tangent point. So here we are going to use sine rule. If you can remember sine rule in high school, or I think it's in high school or in mathematics, but the first time we see sine rule was, I think it was in high school, but not in primary. I think it was in high school. I hope so. So we use sine rule. So now we have been told to get this point, this distance, and this distance. I've already calculated here. Let's just go through. I'm just going to take you slowly, slow. So this, let's name this part here is beta and delta. Let me put my camera correctly so that you can view it properly. Okay. Yes. Now this is beta delta. So getting this the first thing, let's get this angle and this angle. So getting these two angles, getting these two angles, you know the angles of a straight line add up to 180. Angles of a straight line, this is a straight line. We have two angles here, this angle and this angle. So let's assume that this is the one we have been given, this one now, and we are going to get this one. So they add up 180. So take 180 minus the given one, the one we have been given. So this one, we are going to get what? This one, the internal one. Then again, repeat this the same. Take 180 minus this angle, you get this one, and then you get this one, and then now getting the deflection angle, this one. Simple. Take this one and this one, add. You're going to get deflection angle. I've done it here. I've already done it. So take this one, you add, you get deflection angle. Now I'm getting angle of intersection here. How can you get that? Just add this one, which will be deflection angle minus 180. Minus 180 will get intersection angle to be 154. This angle now, it is 154. So this one is intersection angle. Okay. Yes. Now let's start now getting this point, this distance, and this one. So against sine rule, we have distance here, and then we have the angle, given angle, distance, given angle. So you equate the known one to the unknown. Yes. For example, we have the known one, which is EF, and also the angle which is known. We have gotten the angle to be 154. This angle. So this one, the distance should be its distance should be opposite. So we have the distance here, the known distance, and sine this one, which is intersection angle, and this one is an unknown, and this one is known. Yes. So let's use known to get the unknown. Come here. So EI, this distance over this sine rule, is we got this one to be this one. So take this one over its angle is equal to 100 over sine 54, then you cross multiply. Yes, this one times this one over this. Let's put in your calculator. 100 times sine. I'm just confirming from my calculator. 11 degrees, 20 minutes, 00 seconds, divided by sine 154 degrees, 20 minutes, 00 seconds. So this will be my distance here is 45. Let's confirm. I got what? 45 and 7. It's just simple. Just use your calculator. Just multiply times this one, then over this will come here. Simple. Then come to the second one. Let's get the second one there. This part now. Let's say IF sine, its sine is here, sine delta, which is this one, is equal to 100 over, you get with the known one, and then you will get this. Simple. So we have gotten the two both sides, this one and this one. Thank you. So now let's calculate tangent length. The formula of tangent length I've already repeated many times in my videos. Tangent length is equal to r tan theta over 2. So let's calculate tangent length. I think it is done. I've already done it here. So r, which is the radius, 600, tan deflection angle. So deflection angle, I told you deflection angle is just, we had this one was 11 degrees 20 minutes 06 seconds, plus this one you get what, 25. So adding this one it will give you deflection angle, which is this one divided by 2. This one will be tangent length. Yeah, after getting what, that one now. So let's calculate. I think we have already done the first part, which has calculate the distance IF from this one. I've done this one. Yes. Now let's come to this bigger part. Through a chainage of points, this one, tabulate the deflection angles. So before we tabulate the deflection angle, we must first get the chainage. The first chainage, which is we also name it to be T1, and the second chainage, which is T2. Let's calculate this two chainage. For us to get this two chainage, I have the formula. Don't worry. So the distance, for us to get the first chainage, which is T1, we must first calculate tangent length, which we have already gotten here, and then we must have point of intersection. Yes. So tangent length is here, not here. This here. Now chainage of T1. Chainage of point of intersection. This is P1 is point of intersection. Point of intersection. So take the chainage of point of intersection, which is this one, minus tangent length. Here you are going to get this to be T1. Yes, just take this one the one you have been given, minus tangent length. Tangent length we calculated it here. This is the formula. We got this minus, we get T1. Thank you. And getting T2. Getting T2. Getting T2. Getting T2. I've already done it here. We take getting T2 now. Let me first demonstrate for you. Getting T2, we getting this one. We take change of T1 plus take the change of T1 plus hack this one length. So let's calculate the hack length, then plus change of T1. Yes, thank you. So arc length, this is the formula of calculating arc length. This is a deflection angle. It can be also degree of degree of the curve or deflection angle. So the formula here, you have the pi 600, which is radius, times deflection angle of an 80. We go to what? This one. So this one is now arc length. This is arc length, and we got the first chain to be this one plus arc length. We got second chain T2 to be this. Now we have gotten the T1 and T2, chain of T1, chain of T2. Now the second thing, let me draw something here. Second thing, this is arc length, this is arc length, this is T1 and this is T2. This all distance of arc length is 268.78. This is arc length. Yes, this is arc length. So from here to here is this. Now we have been told in the question that curve assume. Let me start from here. We are given the question that assuming that points are required at every 20 meters. Every 20 meters. So now, we have been told at every 20 meters we have a standard chord of every 20 meters. So like this, 20, 20, 20, 20, 20. So now we want to determine how many sub-chords of this kind, of this length will be there. So we take total arc length, which is 268.78, divided by this length of one sub-chord to get the number of sub-chords. We will get what? 13 sub-chords. We will get 13 sub-chords. So we have 13 sub-chords here of 20 of 13 sub-chords of 20 length each. So how many length with this 13 sub-chords with 20 each length will take? So 13 times 20. 13 times 20. 13 times 20 will be 260. So this 13 sub-chord with the 20 length each. Here 20, 20, 20, 20, 20, 13 sub-chords of length 20 will take 260 meters, and the total length of this is 268. So the remaining one, let's minus, just minus. 268, no, 268, no, 268.78 minus 260. You will get 878. This one. So this one we will put it here to be initial code and final subcode. They will share this one. Now the distance from here up to here it is 260 meters, but the total distance from here to here is 268. 260 from here is 260, but all of it is 268. Now let's get what we call initial subcode and final subcode. How can you get this one? How can you get it? So getting the initial subcode, we do this. Take first chainage, which was 915.84. We move it ahead. For example, 910, 920, 930. So after moving it ahead, we will get this one. So we have just moved this chainage ahead to be 920. Now for us to get this first initial subcode, you will take this one minus chainage itself, which is 915, 920 minus 915. You will get the first chainage to be this one. And I've told you that after subtracting 260 from 268, we will get 8.78, which is this distance and this added together. But now we have find the first one to be this. So the last one, we just take this one and minus from here, and then we will get this one. Simple. Just take 8.78 minus the first chainage, which is 416, minus 416. We get 462. So the final subcode, the final subcode will be this one is the first or initial is this one, and the last one or final is this one. I think you've understood. That to that point. I've just demonstrated it. Thank you. So now this is the first initial or first subcode, which is from here up to this is 416, and this one is 462. When you add 416, 4.16 plus 4.62, it will give you this one. And taking this one and adding to 260, you will get the total one. Or let me just add here 4.61 plus 260 plus 4.62. You will get what? 268.7, which is the total one. Very simple. Very simple. Now our question was asking what? Our question was asking tabulate the deflection angles required to set out the curve. Yes, tabulating this one. So now let's get deflection angles for the first code, or for initial code. So initial code, the length of initial code is this. This is the formula. 90 L over pi r. So 90 times distance of the first what? Initial subcode, which is this one, times pi radius. You get what? This one is the initial deflection angle. Now the second one, 90 L final subcode, 90 L times this distance, which is 4.62 pi times 600. You will get this one. Now standard code, this one, we have that in standard code, 90 L times 20 pi times 600. You get one. This is the standard codes. I've gotten this one. So now we are going to tabulate this one. But now we will tabulate this one how many times? 13 times. 1 2 3 4 5 13 times. This one is just first and the last, and this one is 13 times because we have gotten the subchord to be 13 subchords. Now how can we tabulate it? Tabulating, I've already done previous question. Let me just show you points. We have points here. After point we have what we have, let me chainage. After chainage we have chord length. Yes, we have deflection angles. We have cumulative or total deflection angles. You can also call it cumulative deflection angles. Yes. Now the first chainage, first point is T1. Then we start 2 3 4 5 6 7 8 9 10 11 12 13 14. 1 2 3 4 5 6 7 8 9 10 11 12 14, and then we have T2. Yes, and then we have T2. First chainage. The first chainage was here, so we write it here. And chord was 0 degrees. So all of these zeros, just 0. And then the last chainage was this one. We write it here. Yes. Now the first initial length is first subchord length or initial length is here. We write here. When we add this one, we get what? 920. Then chord length. Let me just finish this one. The last or final subchord. We go to what? Final subchord to be 4.62. This one. Just see the way I'm writing it. This one. And what? And this one you will let me count this line. 1 2 3 4 5 6 7 8 9 10 11. I don't want to mistake. 1 2 3 4 5 6 7 8 9 10 11 12. Should be 13 because we have 13 subchords. Yes, we have 13 subchords. It should be 13. So now here you have to cross this one. 1 2 3 4 5 6 7 8 9 10 11 12 13. No, it should be 13 14. Now 15. Then we have T2 now, which is we have the chain of T2. This one 0.62, and here we have the chord length 4.62. Yes. Now, so we are going to repeat the distance chord length, which is 20. How many times? 13 times, because I've gotten 13 subchords. We are going to repeat it 13 times. 20, 20, just 13 times. I want just to be accurate. 20, 20, 20, 20, 20, 20, 20, 20, 20. What's this do? Let's put it on the same line. No, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's think. So now you just add this one and this one. Just add this one, this one, add this one up to this part. Yes. Just add this one and this one and this one. Yes, for example, 920 plus this one will be 940.00, and this one 960. Continue that way up to the last point. Let me go to this part. Yeah, just easy. Just add this one, and this one up to this point. Then this part now, deflection angle. Deflection angle. Yes, first deflection angle was what? This one. We book it here. This one. $55 and the last, and let's say not one, then the last standard, the standard one is here. 0 degrees, 57 minutes, 17. Not so. Let's carry one here. Let's carry one. Let's say 18 seconds. Yes, seconds. And the last one. The last one is this one. 0 degrees, 13 minutes, 14 seconds. Yes, 0 degrees, 30 minutes, 40 seconds. This is the last one. In between here, you will just repeat this one. This one. Repeat up to here. Repeat, please. Repeat. Let's go with me. Repeat. I'm not going to finish. Repeat up to here. Then I'm done. I've said here, just add this one. 980.00. Here, up this point. Yes. Getting this part now. This is part. Just add this one. Do cumulative frequency. I know you know the cumulative frequency. Take this one. Add this one. Add this one. This one will be 0 degrees. 0 degrees. 13. No, 13, 11. Add this one. This one. Let me do for example. So 0 degrees. 11 minutes. 55 seconds plus this one. 0 degrees, 57 minutes, 18 seconds. You add. After adding, don't rub, just continue adding up to the last part. I think I've finished. I'm just finished. So thank you for watching up to this part. I appreciate for staying with me up to this part. So this was the question. If you want to screenshot this, I think this is the question. This is the whole part of the question. I'm just trying to fix it inside the camera. So this was the question for obstacles in simple curves. Yes, so please like, subscribe and share. Thank you.